In the dying days of the Third Reich, as Allied forces closed in from both east and west, German engineers were putting the finishing touches on what they believed would be the ultimate weapon of armored warfare. Weighing nearly 200 tons, stretching over 10 meters in length, and armed with a cannon capable of destroying any Allied tank from distances they could barely see, the Panzerkampfwagen VIII Maus, the Maus, represented the absolute extreme of German tank design philosophy. But this mechanical monster would never fire a shot in anger. It would never strike fear into the hearts of enemy soldiers. Instead, it would become a monument to strategic delusion, a steel cathedral built to worship an idea that had already failed. The year is 1942, and the German Wehrmacht is reeling from its first major defeats on the Eastern Front. The initial thrust into the Soviet Union, Operation Barbarossa, had ground to a halt in the frozen wasteland outside Moscow. German panzer divisions, which had swept across Poland and France with devastating efficiency, found themselves facing a new kind of enemy. Soviet tanks like the T-34 and the massive KV-1 were not only numerous but technologically superior in key areas to Germany's standard panzers. German tank crews reported with alarm that their 37mm and 50mm guns were bouncing off Soviet armor at ranges where they themselves were vulnerable to return fire. This tactical crisis triggered a response that would define German tank development for the remainder of the war. If lighter tanks couldn't penetrate Soviet armor, the solution seemed obvious: build bigger tanks with bigger guns and thicker armor. It was a logical response to a real problem, but it set Germany on a path that would consume enormous resources while delivering diminishing returns on the battlefield. Adolf Hitler himself became fascinated with the concept of super-heavy tanks. A man who had never served in a technical military role, who understood warfare through the lens of willpower and dramatic gestures rather than logistics and industrial capacity, saw in these massive machines a kind of technological magic. If Germany could build a tank so powerful, so invincible, that nothing could stand against it, then perhaps the tide of war could be reversed through sheer superiority of engineering. It was the same thinking that drove the development of wonder weapons throughout the Nazi state, the belief that technological breakthrough could substitute for strategic reality. Ferdinand Porsche, the automotive engineer who would later become famous for sports cars bearing his name, found in Hitler an eager patron for his most ambitious designs. Porsche had already created the Tiger tank's competitor, the VK4501P, which had lost the competition to Henschel's design but found new life as the Ferdinand tank destroyer. Now, in 1942, Hitler personally commissioned Porsche to design something unprecedented, a tank weighing 100 tons, later increased to 180 tons, that would be completely immune to enemy fire while capable of destroying any opposing armor. The project was given the code name Mammoth, before being redesignated as the Maus. The ironic name, suggesting something small and harmless, was typical of German military nomenclature, which often gave diminutive names to their most fearsome weapons. But there was nothing small about what Porsche proposed. This would be a tank that redefined the very concept of armored warfare, a mobile fortress that existed at the absolute limit of what mechanical engineering could achieve. As Allied intelligence began picking up fragments of information about this superweapon program, they struggled to believe what they were hearing. A tank weighing as much as 200 tons seemed impossible, a fever dream conjured by desperate Nazi propagandists. But the Maus was real, and it was already moving from blueprint to prototype. In workshops and testing grounds across Germany, engineers were grappling with problems that had never been encountered before. How do you move something that heavy? How do you power it? How do you get it across rivers when no bridge can support its weight? The answers to these questions would reveal the fundamental flaw in the entire concept. The Maus wasn't just ambitious. It was a technical impossibility masquerading as innovation, a weapon system designed without regard for the basic realities of mechanized warfare. And as Germany's strategic situation deteriorated, as resources became scarcer and the need for practical, producible weapons became desperate, the Maus would stand as the ultimate symbol of the Third Reich's descent into fantasy. The development of the Panzerkampfwagen VIII Maus began in earnest in June 1942, when Ferdinand Porsche received Hitler's direct commission to create a super-heavy breakthrough tank. Porsche, ever the optimist and innovator, threw himself into the project with characteristic enthusiasm. He envisioned a vehicle that would be essentially invulnerable, a tank that enemy forces could neither destroy nor stop. The specifications were staggering: 240 mm of frontal armor, sloped to increase its effective thickness even further. For comparison, the Tiger I, already considered heavily armored, had only 100 mm of frontal armor. The main armament would be equally impressive: a 128 mm KWK-44L/55 gun, the most powerful anti-tank weapon mounted on any operational tank of World War II. This weapon could penetrate the frontal armor of any Allied tank at ranges exceeding 2 kilometers. As a secondary armament, the Maus would carry a 75 mm KWK-44L/36.5 gun in the same turret, providing flexibility against softer targets and fortifications. The turret alone would weigh 55 tons, more than an entire M4 Sherman tank. Porsche's design team faced challenges that pushed 1940s engineering to its absolute limits. The sheer weight of the vehicle meant that conventional tank engines and transmissions simply wouldn't work. Porsche proposed his signature solution, a hybrid electric drive system. A massive gasoline engine, initially a Daimler-Benz MB509 V12 aircraft engine producing 1,080 horsepower, later replaced with the MB517 diesel producing 1,200 horsepower, would drive electric generators. These generators would then power electric motors connected to the tracks. This was the same system Porsche had proposed for the Tiger, and which had been rejected in favor of Henschel's more conventional design. The hybrid drive system had theoretical advantages. It eliminated the need for a complex mechanical transmission, reduced the number of moving parts, and theoretically provided better control at low speeds. But it also added enormous weight and complexity, and the electrical components were vulnerable to damage. More critically, the system was inefficient, consuming fuel at a prodigious rate. The Maus would have a maximum range of only 186 kilometers on roads, and far less across country. For a tank weighing 188 tons in its final configuration, this meant it would spend more time being transported or refueled than actually fighting. The design included other innovations born of necessity. Because no bridge in Europe could support the Maus's weight, Porsche designed the tank to ford rivers underwater. A snorkel system would provide air to the crew and engine while the tank crawled along the riverbed. The entire hull was sealed, and a second Maus would provide electrical power via cable to the submerged vehicle, as the electric motors could function underwater but the engine could not. It was an elegant solution to an impossible problem, but it revealed the fundamental absurdity of the whole project. The tank was so heavy it couldn't use bridges, so it had to drive underwater, a capability that would require perfect coordination, specialized equipment, and conditions that would almost never exist in actual combat. By December 1943, the first prototype hull was completed at the Alkit factory in Berlin. The size of the vehicle was difficult to comprehend even for those who had seen the blueprints. At 10.2 meters long, 3.71 meters wide, and 3.63 meters tall, it dwarfed every other tank in existence. The track width was 1.1 meters, necessary to distribute the enormous weight and prevent the tank from simply sinking into the ground. Even with these massive tracks, the Maus exerted a ground pressure of 1.45 kilograms per square centimeter, higher than most contemporary tanks despite its size. The first prototype, later designated V1, was completed without its turret and underwent initial mobility trials. The results were discouraging. The massive vehicle struggled to reach its theoretical top speed of 20 km per hour on roads, and cross-country performance was abysmal. The tank's width meant it couldn't traverse many roads without destroying civilian infrastructure. Its weight made it impossible to transport by rail without special reinforced flat cars, and even then, the loading and unloading process would be a major engineering operation. Meanwhile, the strategic situation that had birthed the Maus was evolving rapidly. By 1943, Germany was losing the war of production. The Soviet Union was churning out T-34s by the thousands. American factories were producing Shermans at a rate of nearly 2,000 per month at peak production. Against this industrial avalanche, Germany needed tanks that could be built quickly and in quantity. The Maus required thousands of man-hours to construct, used scarce materials that could have built dozens of more practical vehicles, and demanded precision manufacturing that few facilities could provide. Albert Speer, Germany's Minister of Armaments and War Production, understood this reality. He was a technocrat who believed in rational resource allocation and practical weapons systems. The Maus offended every principle of efficient war production. In October 1943, Speer recommended the project be cancelled. But Hitler, still captivated by the promise of wonder weapons, personally ordered development to continue. A second prototype, V2, was authorized, this one to be completed with its full turret and weapon systems. The division between fantasy and reality was now complete. Germany's leadership was pursuing a weapon that existed more as a symbol of technological prowess than as a practical instrument of war. Every ton of steel, every skilled worker, every hour of engineering time devoted to the Maus was time and material that couldn't be used to produce the Panzer IVs, Panthers, and Stoogie 3s that were actually holding the line against Allied advances. The Maus was consuming resources that a starving war economy could not afford to waste. The first Maus prototype, V1, began mobility trials in December 1943 at the Kummersdorf Proving Grounds south of Berlin. From the very first test, the fundamental problems with the super heavy tank concept became impossible to ignore. The vehicle could barely move under its own power. The hybrid electric drive system, while theoretically sound, struggled to push the massive hull through anything but ideal terrain. On hard-packed roads, the Maus could achieve approximately 13 km per hour, far below its theoretical maximum of 20. And a fraction of the speed of contemporary medium tanks like the Panther or T-34, which could reach 45 to 55 km per hour. Cross-country performance was even worse. The Maus would bog down in soft ground that other tanks could traverse easily. Despite its wide tracks, the sheer weight of the vehicle meant it sank into mud, sand, or soft earth. Once stuck, the tank was nearly impossible to recover. No recovery vehicle in the German inventory could tow something weighing 188 tons. Engineers calculated that it would take at least 3 heavy recovery half-tracks working in concert, and even then, extraction would be a multi-hour operation that would be impossible under combat conditions. The engine proved to be chronically unreliable. The MB-509 aircraft engine, never designed for the sustained operation required in a ground vehicle, overheated regularly. The cooling system, already pushed to its limits, couldn't cope with extended operation. During one test, the engine caught fire, nearly destroying the prototype. The decision was made to switch to the MB-517 diesel engine for the second prototype, but this engine also struggled with the demands placed upon it. The fuel consumption was astronomical. The Maus consumed approximately 500 liters of fuel per 100 kilometers on roads, and even more cross-country. For comparison, a Panther used about 200 liters per 100 kilometers. The electric drive system introduced its own complications. The generators and motors were heavy, complex, and vulnerable to mechanical failure. The electrical connections required constant maintenance, and were susceptible to damage from vibration and shock. In combat conditions, where tanks routinely experienced violent jolts from rough terrain and near-miss explosions, the delicate electrical components would be a critical vulnerability. Moreover, the electric motors had limited cooling, and prolonged operation at low speeds, exactly the kind of fighting a breakthrough tank would need to do, caused them to overheat. By March 1944, the second prototype, V2, was completed with its full turret installed. This was the first time a Maus existed in its complete combat configuration, and the sight was both impressive and disturbing. The turret was a massive steel dome, its 240mm frontal armor sloped at 45 degrees, giving it an effective thickness of nearly 340mm against direct fire. The 128mm main gun protruded like the barrel of a naval weapon, which in some sense it was, adapted from anti-aircraft guns used to defend German cities from Allied bombers. Gunnery trials revealed another set of problems. The enormous turret, weighing 55 tons, required a powerful traverse mechanism. The hydraulic system designed for this purpose was sluggish and unreliable. Traversing the turret a full 360 degrees took over a minute under ideal conditions, an eternity in tank combat, where the ability to quickly engage threats from different directions could mean the difference between life and death. Allied tanks could traverse their turrets in 10 to 15 seconds. The Maus would be at a severe disadvantage in any engagement that required rapid target switching. The gun itself performed well in firing tests. The 128mm KWK-44 could indeed penetrate any Allied tank at extreme range, and the accuracy was acceptable given the massive size of the mounting platform. But this combat capability existed in a vacuum, disconnected from the realities of how the tank would actually be employed. Yes, the Maus could destroy a Sherman at 2,000 meters, but it would take the Maus 10 minutes to drive that distance, while the Sherman could cover the same ground in less than 3 minutes. By the time the Maus arrived at the battlefield, the tactical situation would have evolved beyond recognition. Testing the underwater forting capability proved to be particularly problematic. The concept required 2 Maus tanks working in coordination, one providing power to the submerged vehicle via thick electrical cables. The procedure was complex and time-consuming. First, the tank to be submerged had to seal all hatches and activate the snorkel system. Then, it would enter the water while maintaining cable connection to the power-providing tank on the shore. The submerged Maus would crawl along the river bottom at a maximum speed of about 3 km per hour, guided by compass bearings and dead reckoning, unable to see where it was going. During trials in a controlled environment, the system worked, but barely. The snorkel system was vulnerable to damage or misalignment. If water entered the engine compartment, the tank would be disabled and potentially lost. The crew would be trapped in a sealed steel coffin at the bottom of a river, dependent on the successful operation of equipment that was already proving unreliable under ideal conditions. In actual combat, where conditions would be chaotic and enemy fire would be a constant threat, the underwater forting capability would be effectively useless. As 1944 progressed, the strategic situation for Germany became increasingly desperate. The Eastern Front was collapsing under the weight of Soviet offensives. Operation Bagration in June 1944 destroyed Army Group Center, eliminating 28 German divisions and creating a gap in the German lines that could never be fully closed. In the West, the Allied landings at Normandy in June opened a second front that began consuming German resources at an unsustainable rate. Germany needed tanks, but it needed practical, producible tanks in large numbers, not experimental giants that consumed resources while providing no combat value. Albert Speer renewed his efforts to cancel the Maus program. The statistics were damning. The resources used to build one Maus could produce approximately 6 Panther tanks. Those 6 Panthers would have greater combined firepower, better mobility, easier logistics, and far more tactical flexibility. They could be deployed in different sectors, repaired more easily, and transported by standard rail cars. Every rational analysis pointed to the same conclusion: the Maus was a waste of precious resources. But the program continued, driven by Hitler's personal fascination and the institutional momentum of a project that had already consumed so much time and money. Engineers continued testing, documenting problems, proposing solutions to issues that ultimately stemmed from the fundamental impossibility of the design concept itself. The Maus was a solution in search of a problem, a weapon designed for a war that existed only in the fevered imaginations of men who refused to accept the reality of Germany's strategic position. By late 1944, the fantasy of the super heavy tank program collided with the brutal reality of Germany's collapse. The Red Army was advancing into Poland, driving toward the German border with overwhelming force. In the west, Allied armies were fighting their way through France, liberating Paris in August and pushing toward the Rhine. German cities were being reduced to rubble by round-the-clock bombing campaigns. The infrastructure needed to support advanced weapons development was literally being destroyed even as engineers worked to perfect systems that would never see combat. The production facilities at Kummersdorf and Alkut were operating under increasingly difficult conditions. Air raids disrupted work schedules. Supply lines for critical materials broke down as transportation networks were targeted by Allied bombers. The skilled workers needed for precision manufacturing were being conscripted for infantry service or diverted to more urgent projects. Every aspect of the Maus program was affected by the deteriorating strategic situation, yet the project persisted like a ghost that refused to acknowledge its own death. In November 1944, Albert Speer finally succeeded in convincing Hitler to officially cancel the Maus program. The order came too late to recover the resources already expended, but at least it prevented further waste. By this point, only 2 prototypes existed. V1, still without its turret, had served primarily as a test bed for the mobility systems. V2 was complete with turret and armament, but had never been deployed to a combat unit. Plans for mass production, which had at various points called for between 150 to 200 Maus tanks, were quietly shelved. The factories that would have built them were instead ordered to focus on producing more conventional tanks and self-propelled guns. The cancellation of the program did nothing to solve the problem of the 2 existing prototypes. These 188-ton monsters still existed, still consumed resources for maintenance and security, and still represented a potential intelligence windfall if they fell into enemy hands. As Soviet forces drew closer to the testing grounds at Kummersdorf, German commanders faced a difficult decision. The Maus tanks were too valuable to abandon intact, too heavy to move to a safe location, and too symbolic to simply ignore. In March 1945, with Soviet artillery already audible in the distance, German engineers received orders to destroy both prototypes. The method chosen was pragmatic. Demolition charges would be placed inside the hulls and turrets to disable the vehicles beyond repair. But even this final act revealed the Maus's fundamental impracticality. The armor was so thick that standard demolition charges were insufficient. Engineers had to use massive shaped charges, normally reserved for destroying fortifications, to breach the armor and ensure the internal components would be destroyed. The demolition teams worked quickly, aware that Soviet advance units could arrive at any moment. They placed charges in the engine compartments, the turrets, and around the ammunition storage areas. The explosions, when they came, were powerful enough to be heard for kilometers. The V1 prototype was severely damaged, its hull cracked, and its engine compartment destroyed. The V2 prototype suffered damage to its turret and running gear, but remained more intact due to incomplete placement of charges before the demolition team had to evacuate. When Soviet forces overran Kummersdorf in April 1945, they found the wreckage of the Maus prototypes amid the rubble of the testing grounds. Soviet intelligence officers and technical specialists were immediately interested. Despite the damage, these were unprecedented vehicles, representing the absolute extreme of German tank development. The decision was made to recover what remained and ship it back to the Soviet Union for evaluation. Soviet engineers faced the same problem that had plagued the Maus program from the beginning. How do you move something this heavy? Using heavy-duty recovery equipment and specially reinforced rail cars, they managed to load what remained of V2 onto a transport. The damaged hull of V1 was deemed too destroyed to be worth the effort of recovery, though some components were salvaged. The partial remains of both prototypes were later combined at the Kubinka Tank Museum outside Moscow, where the turret of V2 was mounted on the hull of V1 to create a single display vehicle. This composite Maus, the only one remaining in the world, stands today as a monument to misguided ambition. Visitors to Kubinka can walk around the massive vehicle, can appreciate the impressive thickness of its armor, and the size of its main gun. But they cannot see it move, cannot witness it struggle to climb even modest inclines, cannot experience the deafening roar of its engine consuming fuel at a rate that made strategic deployment impossible. The museum display shows the dream without revealing the nightmare of its actual capabilities. In the final analysis, not a single Maus tank ever served in a combat unit. Not one was deployed to the front lines. Not one fired its main gun in anger at an enemy target. The entire program, from initial concept in 1942 to final destruction in 1945, produced nothing of military value. Thousands of man-hours, scarce materials, and the efforts of Germany's best engineers resulted in two prototypes that existed primarily as proof that the entire concept was fundamentally flawed. The Maus represented the ultimate evolution of German tank design philosophy taken to its logical extreme. If bigger tanks were better, if thicker armor was the answer, if larger guns were the solution, then the biggest tank with the thickest armor and the largest gun should be the ultimate weapon. But this logic ignored everything that made tanks effective in modern warfare: mobility, reliability, tactical flexibility, and the ability to be produced in sufficient numbers to actually affect the course of battles. The Maus had none of these qualities. The story of the Panzerkampfwagen VIII Maus is not merely the tale of a failed weapon system. It is a case study in how strategic delusion, combined with technological hubris, can lead an entire nation to waste precious resources on fantasy solutions while real problems go unaddressed. The Maus program consumed materials, labor, and engineering talent during a period when Germany desperately needed practical weapons that could be built quickly and deployed effectively. Every hour spent perfecting the Maus was an hour not spent improving the Panther, not spent solving the logistical challenges of tank production, not spent developing the defensive weapons systems that might have actually slowed the Allied advance. The immediate aftermath of the Maus program saw both the Allies and Soviets attempting to understand what had driven Germany to pursue such an impractical design. Intelligence reports from captured engineers revealed a pattern of development driven by Hitler's personal fascination rather than military necessity. The Führer's enthusiasm for wonder weapons, for technological solutions that would somehow reverse Germany's declining fortunes, had created an environment where rational analysis was subordinated to wishful thinking. Engineers who raised practical objections were told to solve the problems, not question the concept. Industrial planners who pointed out resource constraints were accused of defeatism. The Soviet Union, having captured the Maus prototypes, conducted extensive testing and evaluation. Soviet tank designers learned valuable lessons, but not the ones Germany had intended to teach. The Soviets concluded that super-heavy tanks were a dead end, that the future of armored warfare lay in balanced designs that could be produced in quantity. While the Soviets did experiment with heavy tank designs in the late 1940s and early 1950s, including the IS-3 and IS-7, they never pursued anything approaching the extreme specifications of the Maus. The practical limitations observed in the German prototypes convinced Soviet planners that mobility and producibility were more valuable than maximum armor protection. Western Allied forces drew similar conclusions. American and British tank designers examined captured German documents and concluded that the Maus represented everything wrong with German tank development. The United States had its own experience with heavy tank development, including the M6 heavy tank and later the M103, but these vehicles never approached the excessive specifications of the Maus. The American philosophy emphasized air transportability, mechanical reliability, and ease of maintenance, qualities entirely absent from the German super-heavy tank concept. The resources consumed by the Maus program can be quantified in hindsight, and the numbers are staggering. Conservative estimates suggest that the materials used in the two Maus prototypes could have produced at least 12 Panther tanks or 20 Panzer IV tanks. The man-hours of engineering work could have improved production processes across German tank factories, potentially increasing overall output by several percentage points. The fuel consumed in testing could have supplied a Panzer division for several days of operations. Every metric of resource efficiency condemned the Maus as a catastrophic misallocation of Germany's dwindling industrial capacity. But the true cost was not merely material. The Maus program represented a fundamental failure of strategic thinking at the highest levels of the German leadership. It revealed how completely Hitler and his inner circle had lost touch with the realities of industrial warfare. In an era when the outcome of battles was increasingly determined by which side could bring more tanks, more planes, and more guns to the field, Germany was pursuing quality over quantity to an absurd extreme. The Germans had forgotten that in modern warfare, 10 mediocre tanks in the field are worth more than one perfect tank still in the factory. The Maus also illustrated the dangers of letting political leadership override technical expertise. Engineers working on the project understood its limitations from early in the development process, but their concerns were dismissed or ignored. Ferdinand Porsche, brilliant as he was in automotive design, was fundamentally unsuited to design a practical military vehicle. His electric drive system, his underwater fording concept, his approach to armor protection, all showed impressive engineering creativity but fundamental misunderstanding of what made tanks effective in combat. A weapon system designed by engineers who never had to actually use it in battle, overseen by political leaders who understood warfare through propaganda films rather than logistical reality, could only result in failure. The psychological impact of the Maus program should not be underestimated. German tank crews, fighting desperate defensive battles against overwhelming odds, knew that somewhere in Germany, resources were being devoted to building giant tanks that would never help them. Factory workers producing Panzer IVs knew that skilled workers who could have been increasing production of needed vehicles were instead assembling prototypes that served no military purpose. This awareness contributed to the growing sense of betrayal and disillusionment that characterized the final year of the war for many Germans. Today, historians studying the Maus program see it as emblematic of the Nazi regime's broader failures. The same combination of technological fascination, strategic delusion, and refusal to accept reality that produced the Maus also produced the V-2 rocket program, which consumed enormous resources while achieving negligible military effect. It drove the development of jet fighters that arrived too late and in too few numbers to affect the air war. It led to the construction of massive fortifications and wonder weapons while the basic needs of frontline soldiers went unmet. The single surviving Maus at the Kubinka Tank Museum stands as a physical monument to these failures. Visitors who examine it today see impressive engineering, certainly. The massive armor plates, the enormous gun, the sheer size of the vehicle, all command a certain respect for the technical achievement involved in building such a machine. But informed observers also see the desperation, the denial, the tragic waste of a nation's industrial capacity in pursuit of a weapon that could never have changed the outcome of the war. In the end, the Panzerkampfwagen VIII Maus failed not because of any single technical flaw, though it had many. It failed because the entire concept was based on a fundamental misunderstanding of what modern warfare required. It was a weapon designed for a war that existed only in imagination, built by a regime that had long since lost the ability to distinguish between propaganda and reality. The Maus was not destroyed by enemy action, not defeated in battle, not overcome by superior Allied weapons. It was defeated by physics, by logistics, by the simple mathematical impossibility of making a 188-ton vehicle tactically useful. It was a complete failure because it was designed without regard for the most basic requirements of military utility. It had to be able to get to the battlefield, had to be able to operate when it arrived, and had to be worth the resources expended to build it. The Maus met none of these requirements, and its failure was therefore total, complete, and inevitable from the very beginning.